To understand our place in the cosmos, we start right here. This is our home. Every person you have ever known and every single piece of human history is contained on this tiny blue dot suspended in the dark. But the moment we leave our atmosphere, the way we measure distance breaks down. The moon is about 384,000 kilometers away. If you could drive a car directly upwards at a constant 100 kilometers per hour, it would take you over 160 days of non-stop driving to reach it. Scaling up to the speed of a commercial jet flying at 900 kilometers per hour barely changes the perspective. At that speed, it would take 19 straight years to cross the 150 million kilometers to the sun. And our neighboring planet, Mars, presents a constantly moving target. Because both Earth and Mars orbit the sun at different speeds, the gap between us can stretch up to 401 million kilometers. Getting a rover onto that rocky surface requires navigating a shifting expanse that would take upward of 50 years to cross in a passenger plane. Everyday speeds and earthly rulers fail to capture the true scale of the solar system. To map our address, we must move past kilometers and miles to adopt an entirely different scale. Heading toward the frozen edge of our immediate planetary neighborhood, we reach Neptune. Even light, racing at 300,000 kilometers per second, takes over 4 hours to make the trip from the sun to this distant ice giant. We have managed to send physical hardware past this point. Launched in 1977, Voyager 1 has been traveling through space for over 4 decades, pushing more than 22 billion kilometers from Earth. In 1990, astronomer Carl Sagan requested that this silent wanderer turn its camera around for one final look at home. From a distance of 6 billion kilometers, our entire world was reduced to a single pale blue pixel. This map illustrates the true edge of our solar system. The inner boundary you see here is the heliopause, where the sun's solar wind finally stops pushing against interstellar space. Surrounding it is the Oort cloud, a massive sphere of icy objects. Notice the axes. Because counting in kilometers is impractical, astronomers use the astronomical unit, or AU, the distance from Earth to the sun. The Oort cloud extends 100,000 AU into the dark. The solar system exists as a massive fading sphere of gravitational influence that eventually yields to the vastness of the galaxy. This graphic compares a single AU to a light year, the distance light travels in 1 year. When we look to Alpha Centauri, our closest neighboring star system, even the AU falls short. It sits over 276,000 AU away. The Voyager spacecraft would need 70,000 years to reach it. To capture the scale of our home galaxy, the Milky Way, we have to measure in thousands of light years. This spiral structure spans 100,000 light years across, containing hundreds of billions of stars, each potentially hosting their own planetary systems. Hidden within one of these outer arms is a microscopic sphere extending 100 light-years in every direction. This is the human radio bubble. It represents the absolute physical limit of our radio and television broadcasts, radiating outward into space. Every signal we have ever produced, starting from those early broadcasts in the 20th century, has only traveled this far. Any civilization living outside this tiny boundary is completely oblivious to our presence. The signals simply haven't reached them yet. The entirety of our recorded history, our cultures, and our technology is effectively an undetectable whisper in the local cosmic wind. Beyond that small bubble, we are effectively invisible. Leaving the Milky Way behind, we enter intergalactic space. Our galaxy belongs to the Local Group, a cluster of more than 50 galaxies spread out across roughly 10 million light-years of empty void. Expanding our view even further reveals the Virgo supercluster. Here, the scale multiplies again, encompassing thousands of individual galaxies spread across 110 million light-years. This massive structure is Laniakea, our ultimate galactic home, spanning 500 million light-years. It contains the mass of 100 million billion suns, bound together in a sprawling web of celestial bodies. Deep within this web lies a region known as the Great Attractor. Notice the motion on the map. This central hub exerts such immense gravitational force that our Milky Way, the Local Group, and the entire Virgo supercluster are slowly being pulled toward it. Earth's full cosmic address places us as a microscopic existence bound within an unfathomably immense web of gravitational currents. Pulling back one final time brings us to the absolute limit of human sight, the observable universe. This sphere stretches roughly 93 billion light-years in diameter. But this presents a problem. Cosmologists know the universe is only 13.8 billion years old. Since nothing can travel faster than light, how can the sphere we see be 93 billion light-years wide? The answer lies in cosmic expansion. Since the Big Bang, celestial bodies haven't just been moving through space. Space itself is actively stretching out, continuously increasing the distances between galaxies. Because of this continuous stretching, there are regions of space receding from us at speeds faster than light. The galaxies within those regions are retreating into the dark, forever out of our view. The observable universe might just be a tiny fragment of an infinite expanse. We are left with the humbling realization that there are regions of space we will never witness, making it all the more important to cherish the sliver we can actually see.